to this Futures Lab seminar, Visualizing the Future, Adapting to a Changing Climate. My name is Tove Stenius. I work as a program secretary for one of SLU's future platforms, SLU Urban Futures. So to start with, I will just present you a little bit of background behind the Futures Lab. In 2019, the Futures Lab idea forms between two of SLU's 4 future platforms, SLU Urban Futures and SLU Future Food. And these casual discussions eventually resulted in a decision to set up a 12-month-long project where 6 researchers got the opportunity to work in multidisciplinary groups, as well as getting a crash course on futuring. The dual aim of the Futures Lab was to strengthen the capacity of the participants to work with the future's focus in research, education, and collaboration, as well as to explore how the future platforms could support multi- and interdisciplinary ways of working with the future's focus. So we did not only want to create the possibility for participants to learn more about how to work with the future focus, but also wanted to take the opportunity to learn about how such processes could be designed and supported. Therefore, the Futures Lab was both an arena for experiments and an experiment in its own right. And then onwards, then in this year, 2022, the Futures Lab takes more of an outward approach where we invite external speakers to a seminar series on futuring, as well as SLU researchers to discussions. So about us then, the organizers, our mission is to support transdisciplinary capacity building for sustainable futures, as well as to improve collaboration between researchers and society. SLU Future Food is a platform for research and collaboration for an ecologically, economically, and socially sustainable food systems, a cross-disciplinary effort to meet tomorrow's challenges. And SLU Urban Futures is a strategic platform that develops and strengthens transdisciplinary research, education, and collaboration in sustainable urban development.
Tove?
Yes?
Sorry, there for some reason we're clipped, the left side of the screen is clipped off. So if it's easiest, it might be better just to do it in the presenter view and just shrink the presenter part so that we can see what's on the left side. I think that would work fine.
Like this?
Yeah,
Yes.
and then if you just shrink or maybe you can't, but it's fine. Now we can see the whole screen at least. Thank you.
Good. Thank you for telling me. Yes, thanks, Ishi. The agenda for today is that we have 2 very interesting speakers who will tell us about their views on climate work and futuring. The first one is Erik Kjellström from SMHI, and the second one is Helena Björn from Lomma municipality, and Ishi, who just spoke, our moderator, will present them more closely later. After this, we have a short break, 10 minutes. Please stay around if you want to take part of what comes after the break, which is an internal discussion on how SLU can use this knowledge and these insights in our own organization and research. And then we round off at 3 o'clock. A few reminders before I hand over to Ishi then. Turn off your microphones when Erik and Helena are speaking. Also, we will film the presentation parts of the meeting. We will not film the question parts or the discussion. So if you want to not be seen, please turn off your cameras, take away your names from this Zoom box. So then that way you won't be identified. And for those who are joining the internal discussions, please note down any additional questions and save them for that discussion. And please re-enter again or stay around, just grab a coffee and come back to the meeting at 14:10. So over to our moderator. Ishi was one of the researchers in the Futures Lab, the original version. And he's a senior lecturer in ecosystem ecology, specializing in urban blue-green infrastructure and climate adaptation. He works at SLU Alnarp at the Department of Landscape Architecture, Planning and Management. So Ishi, we are super excited to hear, just before we hear our speakers, a few views from you on your experience from the Futures Lab and anything else you have to tell us.
Yes, thank you. I'm excited too. It's really an honor to be here, and I'm really looking forward to the presentations and the discussion afterwards. And yeah, just to say a few words, I was fortunate enough to get the chance to take part in Futures Lab Phase 1. And there was a small group of researchers from different fields within SLU that applied for and got into this program where we were exposed to ideas and methods about future studies, and to get to try out some of these methods and work together with them periodically for a year. And I came in completely naive about how one might approach studying the future. And after a year of meetings and collaborations with this amazing group, I'm slightly less naive, I would say, maybe just enough to be a little bit dangerous, you know, with the method, some of the new ideas and methods that I picked up. And I feel like a world of really interesting tools and perspectives have been opened up for me. Some of these I've ended up using in research proposals, as well as in courses that I'm teaching or helping to teach. You could go to the next slide now, Tove.
Thanks.
Thanks. And this is just an example, brief example of one of these projects that we ended up doing. I ended up doing for towards the end of the course. This shows, some of you will be familiar with this probably if you've done anything with future studies, but it shows a way of visualizing several different scenarios for the future, and it's called a fyrfältare, or four-fielder. And you just basically select two variables, in this case, climate change and growth or shrinkage of the city. And that those two axes define four different regions of potential future that you can then build, you envision futures that might have these different characteristics. And in this case, this was a four-fielder that I used to help guide an exercise in an architecture and landscape architecture design course at the University of Cincinnati, where a colleague of mine, Eileen Gu, was, or Yvonne Gu, was teaching her students. And so we presented the students with these different scenarios, not giving them a lot more detail than that, but envision, you know, what your city might look like in, you know, at the year 2050 under these different scenarios, with small groups taking each one. Carried out a workshop working on this together with local expert stakeholders from the city that actually work, like some of the people that like the speakers that we have here today with expertise in managing landscapes for climate change, for instance. And then they came up with ideas about what that future might be. And also the really fascinating thing to me, you could go to the next slide now, is the way that futures studies can marry a kind of technical analytical approaches with creative approaches. And one of the things the students did in this class, it's a visualization focused class, was actually create cartoons, each of the small groups for each of the scenarios. In this case here, this is just an example of one of the scenarios that had to do with rapid urban growth compounded by drastic climate change. And so, you know, they're envisioning quite extreme changes, both in society, economically, and in the environment in the city of Cincinnati, if the trajectory is reached. It's a very different approach, obviously, than a kind of a quantitative modeling approach of how the future might look like. And that is also a key and important tool. I think we're going to hear more about some of those tools today. So I will just say it was a very exciting and rewarding process for me. I was thankful to have such a group of colleagues as well, which I think a key thing to remember and realize about this kind of studies is that it's a shared experience, that envisioning the future is a shared endeavor. Helps a lot to have comrades and colleagues, each with different backgrounds, visions, ideas about what the future could be and what it should be. And it's this exciting mix of creative and analytical approaches that I think really lets us take leaps forward sometimes. So I'm excited and thankful to have such a big group today of you that have chosen to spend your afternoon with us. Particularly excited to have our two guest speakers. You could go to the next slide to it. That come with their own special expertise and backgrounds, and each of whom play a direct role in society in terms of understanding and predicting and planning for the future. In this case, around climate change issues. So the guests are Erik Kjellström of SMHI and Helena Björn from Lomma commune. And so without further ado, I will go ahead and introduce the first speaker. That's Erik Kjellström. He's a professor in climatology at the Rossby Center in the research department of the Swedish Meteorological and Hydrological Institute. And development of climate models, production and analysis of climate change scenarios are central to his work and everyday activities at the center, and he will be presenting some of those today. Another major activity relates to support for climate change impact analysis and work on climate change adaptation. And he's also a member of the Swedish National Expert Council for Climate Adaptation. So we're very excited to have him here today, and I will hand it over to you now, Erik. Take it away.
Thank you very much for that introduction, and thanks for inviting me to this event. It's very exciting. I've shared my screen now, so I would just like to hear an okay that it works so that someone can tell me that you see. Okay, excellent, good. Thank you. So I will talk about climate models, of course, since this is my field of work and what we work with. So this will be the primary thing here. And just to show you what I will also talk about, I will talk a little bit, of course, about the future, as that's the theme here. So future climate change in Sweden, that's one major topic. But it's also interesting to me as a climate scientist to be able to try to help with information that is useful or even necessary for climate change impact studies and for the work on climate adaptation in the society. So these are the three kind of topics. And the first one, I will actually go through a little bit what climate modeling is about. And it will not be a long lecture, but I will even show you some complex equations in this, and it will be quite fast. So bear with me for a few minutes now on this. So speaking about the climate models, the models, of course, they should depict the climate system. So this is the climate system in a graph, and we need to, in a climate model, describe the different parts of the system, the atmosphere, the oceans, the land surface, lakes, ice, etc. And also all of the different processes within these different parts, and also the exchange processes between these parts. And in addition to that, there are also external forcing factors like changes in the solar radiation, and also changes in when man is emitting greenhouse gases, etc., to this system and changing it. So this is what we need to describe. And what climate modeling is about to set up numerical models so we can make calculations and computations on this. And these calculations are made for volumes or small grid boxes like this in the atmosphere and in the ocean, and these grid boxes are then the places where we make our calculations. And each and every one of these, and in a large global model, it's much more than thousands. It can even be on hundreds of thousands of these grid boxes, and for each of them we make a lot of calculations, and the grid boxes are also talking to each other. So if there is a wind, for instance, bringing moist air from one area to another one, this is of course something we need to describe in the model. So without further ado, here is now the first equation of this talk, and this is the thermodynamic equation in a partial differential equation form. And I will just very simply describe what this is all about. So this is about how temperature is changing with time. This is the green part here. And this can be expressed by knowing what temperature fields and what wind fields look like in the atmosphere. So if we know that it's warm in one part of the atmosphere, cold in another, and then if we also know the wind direction, we can say something about the tendency here where we are right now. You know, if there is a cold wind blowing towards us, we will get colder in a few minutes, etc. So that's this is quite simple if you think about it, but it can be complex when you write up the equations. The other part here are other things that influence, in this case, temperature, and that can be solar radiation, for instance, or something else. Some processes that heat or cool the system exactly in this point where I'm making my calculations. So that's done for one part of the system, for temperature, but it's also done for other parts, like, and here we have equations for wind speed and for humidity, etc. So now we are through with the equations, and now we try to apply them on the system. So this is now a weather chart for one day, one specific occasion, where we look at pressure patterns and temperature in the atmosphere. And by now applying these equations to a model here, we can derive tendencies for how things are about to change. And then the nice thing here is that we can add those tendencies to the first state that we had from the beginning, and then we can calculate the next state a couple of hours later, and a few hours later, and a few hours later, etc. So this is the whole art of numerical weather prediction and also climate modeling, actually, how that works in a very simplified way. And these maps here, which looks a bit crazy, even if they have nice colors, they can then be interpreted by meteorologists, for instance, and we can then look at them as weather maps, like the weather forecasters present on the TV, with frontal zones, precipitation areas, etc. So just very quickly, shortly to describe here what's the difference between these different models. In a numerical weather prediction model, an NWP model, it's very, very important to have the correct initial state. We need to know today's weather to be able to say something about tomorrow's weather, and that's really fundamental. So there is a lot of attention to working with analysis in weather forecasting. Millions of observations that goes into these observations every day, so that's really important. After a few days, if you run a weather forecast, it will start to diverge from the real condition in the atmosphere, and we can't make predictions for longer timescales than about a week or 10 days or so. In 2 weeks or 3 months from now, we cannot say what kind of weather it will be on a specific day. But a climate model, or a numerical weather prediction model for that matter, can be run for very long times on the other hand. So we can run them for hundreds of years, and they will produce weather for each and every day in this 100-year time sequence. And then that weather can then be analyzed, as that is also what constitutes climate. So this is what we do. We run models for very, very long time, and then we evaluate them and try to make them perform in a good way. So that's what I was going to say about climate models, actually, how they work. And I have one more slide here, and it's about one of the things that we are struggling a lot with. Since I described before that there are many different processes, and if you remember that picture, they were all from very large-scale processes involving the whole planetary system, more or less, to the very small micro scales, where we are looking at clouds and droplets and even radiation, which is on even smaller scales, actually. And but then we have computational limitations here. We have computers, and they are not that powerful, even if they are sometimes quite powerful. So if you want to set up these models and make calculations for many different grid boxes all over the world, in global climate models that cover the whole system, they are still operated on a relatively coarse horizontal scale, and that's what's illustrated in this graph here. Look at the left map here over Scandinavia, with a model with slightly more than 200 kilometer grid sizes. So it's really huge grid boxes, and the map doesn't look very realistic. You can't even find parts of Skåne or the Stockholm area is even in the Baltic Sea here in this model. And more important, maybe even than that, is that the mountains are too low. The altitude is far too low, so these mountains don't stick. They don't stand up as high as they should, and that means that precipitation will fall on the wrong side, more or less, in such a model. If we go to finer scale resolution, the rightmost one here is about 12 kilometers, and this is the kind of the best climate models we have today, actually, on a regional scale for Europe. And then now the map is much more realistic, and we have these features in a better way. And moreover, it's not just the map and the orography and the topography and land sea mask, etc., but it's also about the processes. If you look at now the satellite picture I put in here in the middle, such a frontal system here with the clouds coming down from the north over Scandinavia, they are of course much better resolved in a high resolution model like the one to the right compared to the one to the left. So that means that higher resolution models are better at resolving many of the things that we want to address with these models. And that's really important for both for climate modelers and our scientists, but also for the information that we can derive from these models. Still, and this is now something for the future as well, we can't even today with the best models that we are using, with the very best models we can do it, but we have not done it yet with in terms of climate change scenarios in large scales, etc. So if we look at things like a big thundercloud that is depicted to the right here with very heavy rainfall associated with it. The current climate models are not very good actually at simulating these features, and that means that we have problems in saying something about extreme precipitation and how that might change along with climate change. We have some ideas about it, of course, but we need to have better tools here actually. So now I've talked about our tools here as a climate scientist. And now I will get on to say a couple of words about future climate change in Sweden according to such models. And the first thing to say here that of course is future is uncertain, but it's also certain in a way. This thermometer here is from something called the Climate Action Tracker, and this is a bunch of people trying to follow really what's happening in terms of global work on mitigating climate change. So they have this nice thermometer indicating where we are today. We are at about 1.2 degrees in a 1.2 degree warmer world compared to in the pre-industrial state, that is here, the end of the 19th century. And we know that we are on our way up since we have a lot of emissions and greenhouse gas content in the atmosphere is increasing all the time. So we know it's going to be warmer in the future. We don't know how much, but and there are some bars up there to the right indicating what current policy says, but also where pledges and targets, etc., try to keep this number as low as possible. But we know it's very certain that we will get an even warmer world in the future. How much is more uncertain, of course. What does that mean then? So if you look at Europe, for instance, now at different degrees of global warming, and these are the numbers on top here, we can see how things like temperature, for instance, change over, in this case, Europe, at different global warming levels then at 1.5, 2 degrees, etc. And we don't know exactly when that might happen, but we have some ideas about that. So warmer everywhere. The highest warming is actually in the far north, where we have less sea ice and snow in the future, and there is a positive feedback mechanism acting here, amplifying the warming. There's also strong warming in the Mediterranean and in mountain areas, etc. We can look at other variables as well, and again the temperature is on top, but now I also added some other things here, like the number of days in winter when we have so-called zero crossings. So these are days when the temperature is both above and below 0 degrees in the same day. And these are days when it's typically slippery on the roads, and we might have problems like that associated with that, with wet snow or freezing rain and things like that. And now we can see here that there is an increase actually of this in the north. So even if we go into a much warmer climate and you think that there will be less problems with snow, etc., conditions related to days with weather when temperature is around 0 could actually become worse in some parts of Europe, including northern Scandinavia, while the colors are green in most other areas where we will most often be above 0 degrees. There are also things happening with precipitation. The global warming leads to an amplification of the global hydrological cycle. That means warmer air can hold more moisture, there is more evaporation from the surface, and that means more precipitation. So more precipitation means wetter conditions, but at the same time, when you have nice weather or sunny weather, I should say, in high pressure situations, the ground can dry up even more. So there is a kind of a struggle here between more or less precipitation, drier and wetter conditions. And for Europe, this means that it will mostly become wetter for Northern Europe, more precipitation. But in summer, this is the third row from the top, you see it in the southern parts of Europe, and also sometimes even reaching almost up to Scandinavia, southern parts. There might even become a lessening of precipitation and a drying in the future climate in summer. So there is a difference between summer and winter here as well. And these are the things that these models are picking up, and what we also to some parts see already now in observations. You can also look at other things, again, precipitation on the mid row, now these annual mean conditions, but then we look also at wind speed conditions here at the bottom. slight decreases of wind speeds. Generally, these are now mean wind speeds, and maybe slightly more number of really calm days also is something that we see. But it's very uncertain, and you have also some areas close to the Baltic Sea that are maybe going slightly in the other direction. And there are some fundamental uncertainties here in our understanding of the climate system that is behind this, but I don't really have time to go into that in any detail. But these are the typical kind of results that we can derive from these models that we are using. So now I will just go then about a few minutes on the last part here, discuss a little bit about how these climate models can be used then in support of climate change impact analysis and climate adaptation. And I have just a few examples, and they are related to the maps I just showed. The first one relates to the warming, and that of course implies that there will be changed heating and cooling demand in the world in the future, and this is what the two maps reflect here to the right, where we have calculated something we call degree days. So that has to do with the need for warming actually. And you can see here from the reference climate a few decades ago until the end of the century in one of the scenarios, there is a strong decrease in this heating demand for this part of the world. In other parts of the world, and also in Scandinavia, there is at the same time an increased demand for cooling. In our part of the world, warming is much more, this is much more important than cooling, but on a global level, actually already today, the cooling demand and energy production needed for producing all the cooling is larger than the energy needed for warming it. So we are already there basically. When you think about the climate system and the energy system, we still, even in the future, we will also have cold winters then. There will still be a variability. So we will have cold snaps in winter as well. And that's why, if you think about the energy system, for instance, you need to still have margins here that you can produce electricity, for instance, even if the climate is much warmer. Another saying something more in detail on this is this one here, saying something more about the cold extremes. And if you look at here to the left, the number of very cold days, and these are days when temperatures are below minus 7 degrees on a daily mean. This is mostly happening in northern Sweden today, not so much down in the south and in Skåne, for instance. This is a very rare thing down there. And then we can see in the right map there with the green colors that this is something decreasing all over the country. Not so much in absolute numbers in the south, but these days will become even less common than in that part of the country. And you can also see it in this probability distributions to the right, and this is now for the Stockholm area. It's a slightly stronger scenario, but you can see a very, very strong shift from the past climate when we had cold winter days to a future climate when the whole probability distribution is much, much more squeezed like this. So the very cold days, they are simply not there anymore. We can also see other things, and this is my kind of final example here, illustrating something on river discharge, and this increasing precipitation but also changing temperature conditions leads then to changes in the discharge in our rivers. And this is now for the river Nissan that ends up in Halland, a bit north of Skåne. And what it shows is that the control climate flow there with a peak in winter and spring, it becomes much stronger, and you can see the red and blue curves. There is a much larger discharge in winter due to the increasing precipitation and the increasing rainfall, while in summer you can see, on the other hand, on the contrary, less water in these rivers. So there are these things are, and here you can use the climate model data, and that's what I want to say here also. You can use climate model data directly to drive impact models, in this case a hydrological model, to calculate these discharges. You can look at this in other ways. These are also results from hydrological models, where we look at, in the middle, there is the average river flow, some increases in the north due to this, not so large changes in the south. And that's because, of course, that temperature is increasing. So even if there is more rainfall, there is also more evaporation. And this is also reflected in the left map, where the number of days with low flow in the rivers are really increasing in the southern part of the country. So that's also interesting. And in the right graph, we can see then the maximum, the really high discharge events, and there we can see decreases up in parts of Norrland in the north, where less snow on the ground leads to a smaller and less and a smaller what is it called? The spring flood is smaller and lower and less severe compared to before. So my very final thing here is then to say that sometimes we can use the data from our models directly into impact models, but sometimes we can't. And sometimes our climate models, they can't really say anything, and we have difficult questions. And this was a project we had related to the energy sector a few years ago, and they asked us about wet snow conditions, blötsnö in Swedish. Will that become more or less severe or problematic in the future? And we said we don't really know, and there is nothing in the climate model that is really blötsnö or wet snow. So we looked at a number of different indices here, and these are the graphs to the bottom, and I will not go into the details here. But the conclusion here was that in the southern part of the country, our judgment was that this is a problem that is really diminishing with the warmer climate. But in the north, and especially in the winter months, we could potentially have a stronger problem with these kind of wet conditions when temperature is close to 0 degrees and there is still wet snow or freezing rain in the air. And that project was done together with people really from the energy sector. So we sat down around the table, discussed this very carefully, and we also used a fyrfältare, as you were talking about the issue, to come up with some consequence analysis for these sectors. And that's also one thing for the future here from my side. So we have to do development of our models, but also to think cleverly about how to use them. So that's also one of these things and learnings for the future as well. Some more information about this can be found at the SMHI pages. We have some map services here, and these are intended to be your tool in this world. While my tool is the climate models, but your tool is more to use the information and these scenarios from our models. And yeah, I would like to finish there, and I also highlight 2 reports recent from SMHI. One is on the climate change information that is needed for adaptation work, and this is the left one, and the right one is not from SMHI, but it's from this expert council that we handed into the government earlier on this year on climate change adaptation. Thank you very much.
Thank you, Erik. Ishi, will you we said we would have some time for just 1 or 2 questions right after each person.
Yeah.
We have 2 questions in the chat.
Yes.
One that I
had
wrote
it there for a second. Well, let's. Well, do you want to just take yours, Tove? Why not?
For sure. Since the climate changes you, Erik, were describing, they have a huge impact on many parts of society. So I was wondering first, what is SMHI's role at the national level when it comes to climate mitigation and adaptation? And also if there are any particular actors or sectors that you collaborate with, and in what ways?
I think for climate change adaptation, SMHI, we have a knowledge node or a knowledge hub. The National Center for Climate Change Adaptation resides here within SMHI. So we have a lot of collaboration with a number of different authorities and governmental agencies, I should say, around the country. So that's collected in something called Klimatanpassningsportalen. You can go in and look at this. So there are more than 20 or 30 or so different governmental agencies working together there, and they are covering a number of different sectors. So I would say that we are kind of quite broad in that sense. When it comes to adaptation, this is not maybe or mitigation. I mean, that's not our main field, but of course we work a bit with what I also showed now on for instance, renewable energy and the energy sector, and that. So there is a clear link there as well, even if we are not really addressing so much how you can reduce your emissions or anything like that, but more on the scientific basis for how you can, for instance, work with renewable energy. I hope that answers your questions at this point.
Yeah, it was a good answer. Thank you. Should we also take the other question right away then?
Sure, I can read that. I don't know if Erik, you can see it, but there's another question in the chat that is, can you solve the question of wet snow in the future when the computers are more powerful? So is it a limitation of computing power, basically?
I think it's maybe not it's not entirely related to that. It's also related to process understanding and how these I mean the wet snow that really relates to microphysical conditions to some extent, and I don't think even if we have super much faster computers and can really make calculations on a 1 kilometer grid, there will still be really sub-grid scale processes. So there is still there will still be issues with that. Maybe of course we can get further than we are today, but I don't think we can solve the question really. Maybe get a little bit more close to it.
Thank you.
Okay.
Yeah, I can go right ahead and introduce Helena. Is that okay, Tuva?
Perfect. Can you see the screen now?
I sure can. Yes, looks good. Yeah, so thank you very much, Erik. And now I'm happy to, we'll just keep it rolling. I'm happy to introduce our second speaker today. That's Helena Björn. Helena is the head of environmental strategy at Lomma municipality. And she has a PhD in ecology and a wide and long experience of sustainable urban planning. During her years in Lomma, she's been part of developing ocean planning, climate adaptation, and ecosystem services in urban planning at the local, regional, and national level, sometimes also at the international level. And the importance of well-functioning ecosystems and how municipal authorities, in keeping with all other actors, can contribute to support these ecosystems are the driving forces of Helena Björn's daily work. So Helena, welcome.
Thank you very much. I have to start by saying that I have a slight post-COVID syndrome, so my voice is so, but I'll do my best. Thank you. And thank you for inviting me to this. I'll just share my screen now, and hopefully this is going to work. Yes. I wanted to talk about the local perspective and some of the problems that I have identified during my years working mainly with spatial planning. And maybe I'm not really sure where you in the audience are from, but I guess you are somehow connected to Alnarp. Is that correct? Yeah. So Alnarp is situated in Lomma municipality, and Lomma then is situated just north of Malmö, but I guess you already know that. And it's also about 25,000 inhabitants, which is good knowledge when you talk about spatial planning and landscape and things. And then I have this picture of buildings because I think it's also very important to know that different municipalities have different drivers in how much you want to build in that region. And at Lomma there's a very high demand on land and very high demand on building different kinds of housing or other buildings. So the demand for land and land use is really a challenge here. And I think that's the same for the whole southwest of Scania, basically. And like Erik said, we face something now, and it has already started quite clearly. We have a problem with flooding, obviously, but also this hard making or sort of changing the land into hard structures is really a big problem, I think. And I think Sweden is really, we don't understand how problematic that is. I think we really have to change how we look at our land use. Drought has really started to show last years. And that's also making effect on landscape level already, I would say. We have a problem with erosion, obviously, because we have our soft beaches. And another problem that we see a little bit of already is more pollution to water because of heavier rain and stuff. And since I've started in Lomma, I've actually experienced at least 12 extreme weather events since 2007. And when I say extreme, I mean they should statistically happen every 70 years or less often. So it's not an ordinary event. It is, but it's still happening now, almost every year. And then I also always need to show this picture because it's about what municipalities do. It's easy to forget what we actually can influence. And spatial planning is in Sweden very different from every other country, I think I know of, because the spatial planning is done on local level. So the municipality has the power of spatial planning. We also have all the activities going on and permits and stuff that we sort of have an influence on. And land use and maintenance is, all of these three boxes are sort of making a change in land use, and it will affect again on a larger level than maybe we anticipated from the beginning. And on top of that, you then have climate change, which will drive all these changes in a direction that you might not want or anticipated from the beginning. So that's a big challenge, obviously. And I started to work with climate adaptation in 2007, and I tried to understand what my role in all of this was, and that was not easy in those days, but I realized that I have to start with getting the facts right. And I actually, SMHI was quite fast, I would say. They started up with tools that municipalities could use for understanding which type of tools we needed to get. And it's about what type of flooding will hit us, what type of other catastrophic events do we have to foresee. And you have to get all these right before you can even start working, actually. And that took a couple of years, and it cost you quite a lot of money. And then when you have these facts right, you can do either action or avoidance somehow. And all of these boxes drop down to different things. But I think when you say climate adaptation, people automatically think flood barriers, but that's just, for me, a tiny box of what we have to work with. Other things that we often forget is, for instance, agreements with landowners or cooperation with a lot of actors in these scenarios. I think this box is actually one of the more interesting ones to talk about today, because I think a lot of the keys are within this. If we don't cooperate, we will never ever solve this. And if I'm working on a municipal level on my own, it's going to be really, really hard if I don't cooperate. Yeah, maybe one more thing on this one, but the physical barriers or the built protection has to spill into the comprehensive plan and sort of be shown, but not only that. And I will come back to what I mean, but you have a few tools on the municipal level that maybe other actors doesn't. So this is my municipality, and this is, you can see the dark green areas, they're actually just 0.5 meters above sea level. And I would say that if you go to +3 meters, maybe 1/3 of the land area is gone. So it's a bit of a problem. So what did we do? This is what I mean. We have to get our facts right. This is the first flooding scenarios we did, looking at different different scenarios to see, is the sea level going to be the problem now, or in what scale are we, time scale are we looking? Will the flooding from the streams be more problematic? And these maps was actually in the comprehensive plan that was produced 2010. We still use them, but they are getting more detailed these days. So we scale both up and down. Here you can see a picture from our new comprehensive plan where we actually rewrote the land line. So the red line is what will be the difference with climate change in about 200 years, meaning a big part of the municipality will be gone if we don't do anything. And this is from, excuse me, this is due to sea level rise. Now we have a big housing area here, Bjärred, and down here is Lomma. Both of these will still be worthwhile protecting. But we have to ask ourselves, what about this area? Oh, wait. Do we have to protect this as well? Is it worth it? Probably not. Oh. So this is a map from the new comprehensive plan again, where the blue and white areas here are areas that we are actually giving up. These are not areas that we will protect, and there are no new houses going to be built here. We won't allow it, and no one is going to be allowed to develop buildings that already exist. You cannot expand, you cannot convert. So this is basically land that we will not continue to plan more than this. This is abandoned somehow already. Again, then if you look on this picture and sort of feel the landscape here, where you can basically see the old delta almost in the green area. And then you put some historical maps on this, and the red line here is the catchment area of Hydrological River, and down here is Lomma village. Lund is here, and all of the water in this catchment area has to go out through here. And the blue marks are historical water. It's water that used to exist in the landscape that's been drained because of in the 19th century due to need for new land to produce food. But it still gives a very good picture of the landscape in its sort of original shape, being able to take care of water. So since 30 years, we've been working together with Lomma, Lund, Staffanstorp municipalities to create new wetlands. And this has also gone into our comprehensive plan as nature-based solutions for climate adaptation. So we need to work with the landscape and take care of evolving the greenery and the wetlands. And this is exactly what the IPCC new report said in March, that we have to use nature to help us. And this is one of our projects where actually Lomma municipality puts money into Lund's municipality to help build these big landscape changes, basically, where you do larger wetland projects. And this helps us in our municipality. And we want the water to be able to come back where it's supposed to be. So the challenge is then sort of summarized. I think keeping the existing services intact is going to be really, really difficult if we are going to build the way we do now. I think this communication, it is really problematic as well at the moment, because somehow we're in a state where people are a little bit angry. It can be quite defensive. The discussions are almost like no one told me this was going to happen, which is strange, maybe, because we know this is going to happen and we know it's going to be worse. But I think the municipality has a very heavy role here of communicating with its citizens and landowners and industries because we have to work together. Another challenge is all these stakeholders, because they all have different parts. And if you compare, for instance, the systems of Netherlands and Sweden, it's so different because the state has the full right to do everything, but we have to puzzle all the time, and we don't own any land, so we have to come and beg, and can we use this? And no, I don't want to use this. Yeah, but if we pay you this much, no, I don't want to use my land for that. So we don't really go forward in the pace that we need to. And obviously finance is always up as a challenge, because who is going to pay? The municipality can't pay everything, the state can't pay everything, the private sector can't pay everything. So again, we have to cooperate to make this work, but no one really knows how. Still, I'm hopeful. I believe in understanding and multifunction, and I think if we cooperate and get everyone to understand, we will reach these goals. And we have a lot of examples actually with the work we've done in the last 10 years that it can happen, but it's project-wise and it's not enough. Access, and by access I mean work with land use, work with borrowing land for temporary use. For instance, maybe we can have a contract with the landowner to use his land sometimes for flooding, then he get paid, then he can go back to growing until the next event, things like that. Sometimes we need to work with retreats. But then I also want to stress this small scale, because I think we talk maybe a little bit too little about that a lot of small scale solutions actually make a big impact as well. And I think here is something for resourceful people to invent. A lot of small scale solutions that can be used in cities, in farms, where you can do a lot of small things that becomes a big solution altogether. Thanks.
Thank you so much, Helena.
Thank you, Helena. I see we have at least one question in the chat here. I'll go ahead and read that.
Yeah.
We're gonna twist everyone's arm so everyone gets involved in the discussion here soon, but that's fine. The question is Sweden set up for physical planning, putting a big responsibility and freedom on the municipalities, efficient as it comes to adapting to climate change? Many major pros or cons as you see it?
I think I discuss this a lot with other municipalities, and I always say that if you want to have the freedom of spatial planning, you also have to take the responsibility. You cannot claim that the state should pay for all climate adaptation and at the same time say that you should be responsible for spatial planning, because it's, if you do the spatial planning, you have to take the responsibility. So then it's fine. But it's tricky because maybe we are too many small units and it's a lot of work going into this cooperation thingy. So sometimes you sort of wish that, oh, just let the state take everything and take all the responsibility. But at the same time, I think, nah, because the local level is important and there's so much knowledge on the local level that I still believe in this, actually.
Thank you.
I have a question just popped up. Let's take that one. The question is, could you share an ideal collaboration you could imagine for Lomma Commune?
Well, we already have two actually that I'm really, really proud of. It's this, one is the thing that we've actually worked with our rivers in collaboration with up to 9 other municipalities for 30 years. I think that's pretty impressive. And that we work together with the water issues and that it's really, really steady work because we've been going on it for so long. So I'm proud of that, and I think I'm sort of astounded that not more municipalities use this as a resource because it's got so much to give back. I think Lomma, for instance, in our collaboration, we pay about 1 million Swedish crowns a year for doing actions, and at the same time, Lund is paying 6 million. And Staffanstorp is paying 1 million, and then we get 60% funding from the state and EU. So meaning we do actions for about 18 million Swedish, and for that, all of that, we pay 1 million. So that's really good outcome for us. The other is an EU project that you can actually like and have a look at in Bjärred, where we restore the beach as a project, a life project, together with the region, Länsstyrelsen, Ystad and Helsingborg. So we have a really, I think it's been a fantastic project because we've learned so much from each other, and it's really this drive that you learn together, you make mistakes, you're not afraid to talk about the mistakes, and then you use the mistakes to do it better. And I think that's, when you have that kind of openness, it's really fantastic. So process by learning.
Oh, that's inspiring to hear about this long-term collaboration, that it's and maybe that's an important part of the success, I guess, taking a long-term perspective towards the problem and the solutions.
Yeah.
Should we take a small break now before we continue with the internal discussions? And I see that there were some questions posted as well in the chat now, but just bring them with you into the discussions in 10 minutes. I just wanted to share with you, for those of you who have to run and can't join the discussions, the next seminar. It's here, I think. Let's see. Can you see it?
Yes.
Yes. So the next seminar will be on the 21st of September. That's day it will be from 12 to 14, so a proper lunch seminar. And then it's Gary Peterson from Stockholm Resilience Center who will come to talk about his work. So, but please hang on, go grab a coffee or just relax, and then we'll see each other in 10 minutes. Thank you.